Hola, Mr. Lee here. All right, let's solve some word problems. Okay, so these should be two-step equations that are built in these word problems. This should be in your Canvas page or your notes. Okay, this little guide for our equations. So output equals constant plus rate times input. Hopefully, we'll see each of these come into play in these word problems. So let's get into it. All right, so last month, Margot bought a tree that grows 2.5 centimeters each day. It was 5 centimeters tall when she bought it, and now it is 65 centimeters tall. Write an equation to determine the number of days, D, Margot has owned the plant. Okay, so this right here, as you're reading this, right, you guys can mark the text however you need to, but this right here is telling me what I'm going to be solving for. Determine the number of days, D. And then even at the end, right, after you write the equation, it says find the number of days Margot's on the plant. Right? So if you're looking at your your four-step guide, your first step is to mark the text, and then second is to define your variable, right? So I'm going to go straight to the defining the variable, then we're going to write an equation and then solve it. Okay? So I'm basing this off what I highlighted. Find the number of days Margot has owned the plant. So I'm going to say D equals number of days. That's what I'm solving for, right? I'm solving for the number of days Margot has owned the plant. So let's start building our equation. So output is usually the total. So in this description, it looks like the tree grows to a total of 65 centimeters tall, right? The constant should be what it started out as. So it started as a 5 centimeter tall plant when she bought it, right? And the rate, 2.5 centimeters each day, right? The word each, 2.5 centimeters each day should give you a clue on the rate oftentimes. Okay, so it grows by 2.5 each day. And then if you have a rate, you're multiplying it by the number of days, like that, 2.5 times D or 2.5D, right? There's our equation. Okay, so this is what should go on this first line. We're just writing the equation. It gives you that that first step. And then once we solve this, it should give us how many days go by, right? So let's just make sure this equation makes sense, right? We don't know how many days Margot's on the plant, but we're going to take those number of days, multiply it by the 2.5, which makes sense, right? It grows 2.5 every day, so multiply those two together. And then you're adding the initial height of the tree when she bought it, which is like the starting point, plus 5, and it should total 65, so we're good. So let's solve this, okay? So this is going to go pretty fast, but you guys can pause the video if you need. Let's subtract 5 on both sides, and then divide both sides by 2.5. Okay, so we have a calculator to help us out. 60 divided by 2.5 gives us 24. Right? So 60 divided by 2.5 is 24. I'll just leave that there. So our final answer is 24 equals D. Okay? That's kind of how we finalize our answer. So 24 days should pass by. Okay? Let's just do one more. I know word problems for videos go a little bit longer. So let's do one more here. Okay, here's another one. So let's read it together. Carl is boarding a plane. He has 2 checked bags of equal weight and a backpack that weighs 4 kilograms. The total weight of Carl's baggage is 35 kilograms. So I'll write an equation to determine the weight. I already know what I'm solving for, right? If you're reading this carefully, marking the text, to determine the weight, W, of each of Carl's checked bags, right? There's even the final description of what we're being asked. Find the weight of each of his checked bags. Okay? So step 1. Mark the text. I mean, you guys can do that yourself, but we did a little bit of it here, highlighted. And then we want to define the variables. Okay, so they want us to use the letter W. You can use any letter to solve, right? We can use X if we want to do, but let's use W because we're guided to that. So W equals weight of each checked bag. Okay. Weight of each checked bag. There we go. Let's build our equation. Okay, so reread it if you need to. Looks like Carl has 2 checked bags, same weight. He has a backpack, an extra backpack that weighs 4 kilograms. The total weight of Carl's baggage, total weight 35. That should be my output, right? Total is 35. His constant should be his backpack, right? Because he has a backpack plus 2 equally weighted checked bags, which we don't know the weight of. So the constant is 4. And then there's 2 of his checked bags, right? We don't know how much one of them weighs, but we know they weigh equally. So 2 times the weight of one is the weight of both of them. We're trying to solve for the weight. And then we add the extra 4 because we know his backpack weighs that, right? So there should be our equation. Let's type it in. 35 equals 4 plus 2w. Okay, that's kind of, in my opinion, the harder part, right? Creating these equations, making sure it matches the context. Now let's solve this sucker. Okay, so again, this goes fast. Pause the video as you need. Subtract 4 on both sides. You get 31 equals 2w. Divide both sides by 2. Let's let the calculator do the work for us. 15.5. We do get a decimal, okay? So 15.5 equals w. We can say each of the checked bags weighs 15.5 kilograms. All right, there you go.